We're going to cover lectures 6 and 7, which are the last lectures for LU2. Okay. Yeah. So I combine the two lectures. Okay. So lectures 6 and 7, we're going to talk about two population means from two samples. Okay. Before this, what we have covered in the hypothesis testing. This is also actually hypothesis testing. Hypothesis testing is a generic topic. It is just about testing the hypothesis, but it could be one sample, it could be two samples. So in this case, we are focusing on two populations from two samples from two populations. Okay, so this is actually hypothesis testing still. Yeah, continue. Right now, we're gonna talk about two population means. So before this, we talk about one sample, and then we want to compare it with the population, right? One population, one sample, one population. Yeah. So in this topic, we're gonna talk about two population. Okay. Let's say population 1, population 2. And we're gonna compare one sample 1 from population 1 and sample 2 from population 2. Okay, so that's how what the topic is all about, today's topic. Okay, so what we're gonna cover some introduction, and then there are two situations which is actually quite the same with one sample case. When the standard deviation of the population, here we are talking about two populations. So here is actually two populations. When the standard deviation of the populations are known, and also when they are unknown. Okay, so you can see the pattern is about the same. And for the unknown standard deviation of the population, there are two types of samples, independent and dependent samples. Okay, so first let's have a look at the introduction. So here we will also use a t-test. T-test is a test that basically we want to compare two things. We can use t-test, okay? So you're going to use t-test as well, and you're going to use the t-distribution table. Right, so t-test assesses whether the means of two groups are statistically different from each other. So in this case, we are talking about two samples, sample 1 and sample 2. So when we talk about the data of one group, let's say one sample, so it covers actually, it will give a distribution like this one is from, let's say, sample 1, this is from sample 2. So you imagine the whole data is described by the whole graph, okay, the whole graph. So it means like you got from the lowest to the highest, okay, and this one is referring to the mean or the median, okay, but the whole data is actually represented by the curve. This is what we call distribution. Okay, the whole thing is distribution, and it covers the whole data. So last time I got a question from you, from one of you, how we know that it covers, let's say we are talking about percentile. Percentile is like how, to what percentage of the whole data. So if let's say we are talking about to the 93rd, you know, like 93rd, and 93rd is our days. Okay, like let's say this is percentile, it means like 25%. I mean, like it covers the order of the data, isn't it? So if let's say regardless of the number, let's say you want to know 95th data. Okay, so of course, if you are talking about the whole data, this is the whole data, which is 100% data, right? So you want to know what is the data on the 95th point position. So if you are talking from the lowest, from the earliest to the whatever the 90, let's say 95th, so it should cover from here up to, if let's say this is 100%, so 95 could be somewhere here. Yeah, so it should cover everything. So if you see the whole data, it should cover from the left to the right. Okay. Although if let's say you refer to the standard Z normal, this standard normal distribution or the Z table, the Z table only give you the right side for you to calculate because it assumes symmetry, right? So once you know the left, the one of the side, you can apply it for the left side. But in terms of the whole distribution, we are talking about the whole thing that is from the left to the right. So that's why we have to also consider the this left axis and this is right. Okay, so I hope you understand the concept of distribution. It covers the whole data and is represented by this curve. Okay, well, this is just a general part or general pattern of distribution. Okay, so now when we're talking about two samples, two data, two distributions. So of course you expect there are two distributions because each of that has its own data range. So if let's say we want to compare two distributions, so this is I mean we're going to like see whether the distribution match or not to each other, how much. For example, like when you plot it this way, you can see whether the data are similar or not. Okay, so that's how the statisticians compare the two distributions or the data from two groups. Okay, so when we have these two distributions combined together, so what we're gonna observe or analyze in terms of the variability. Variability is how, referring to how wide the distribution is. Okay, how wide the distribution is. Wide means like, if you see here, this one is with the highest variability compared to the first and the third. So this one is medium and this one is blue, because this one is, you can see that the range, the width is very small compared to the other two. And this one is the largest width. Width is like how the distribution span, okay? Largest width, and this is the smallest. In this case, smallest width, and this is medium. This is medium. So based on that, if let's say we have this comparison, we can say that the second one here has the highest variability, because the width is referring to variability, how varied it is. Yeah? So if it is small, it's not that really varied from the data. So that's why this one has low variability. And then apart from the variability, we can also compare between the two distributions, whether they overlap or not. How much the overlap. Okay? For example, this one, you can see this one. The third one here has the least overlap, isn't it? You can see the two distribution doesn't fall into that similar area that much. It's only this area. But for the second one here, it has the highest overlap. Can. So it means that it's very close. The distribution is very close. And this one is medium. Okay, so there are two things that we focus on when we have two distributions. How variable it is, variability, in terms of variability, and the overlap. Okay, overlap. Okay, so that's how you basically compare two distributions. So now let's move to the calculation part. We're going to talk about the first case first. statistical analysis of two population means. Okay, now you remember that we are talking about two populations and we take samples from the two populations and we want to compare that two samples whether they are similar or not. So in statistics, we talk about comparing a lot because that would be the basis for the conclusions. Whether if let's say you are doing research, you have the data from place, whatever the place, right? Let's say location 1, location 2. You have whatever the data. So it's not just specific. It can be anything, the data. Okay. So we want to compare location A and location B. Are they the same? Are they similar? Are they different? So they have to undergo the statistical analysis. Okay, so that's the reason why in statistics we talk about comparison a lot. Okay, right now, the first case here, the standard deviation of the populations are known. Both populations, we know about it, the standard deviation. So that's going to be the statistical analysis that we're going to have a look. Okay, so the statistical analysis, when we talk about statistical analysis, it comprises a series of steps, like similar with the hypothesis testing. Last week, we talked about the steps, right? So we set the hypothesis, identify the level of significance or the alpha, and then compute it. Okay, but this one is quite the same, but it's just that in terms of the calculation here is going to be a bit different. But at the end, we want to make a decision. We want to conclude which hypothesis that we're going to accept. Okay, but it's just that here the hypothesis could be a little bit different because we are having two populations. So you have to define your hypothesis correctly, unlike the one sample and one population. Okay, now let's have a look first at the steps. So the first step is to set the hypothesis, both null and alternative hypothesis. Second step is to set the alpha or define. Okay, sometimes it's given, so you just put whatever the value given to you, or if it's not given, you have to define. Okay. The third step here is to compute the Z value. Okay, since now here, this one is known, so it is also similar to the one sample case. You use Z distribution. Okay, so you can see there are lots of similarities. So you can, you can predict how the steps will be. Okay, so Z distribution means here you have to calculate the Z value. Calculate the Z value. The fourth step is to compare the tabulated Z is the Z from the table. You have to determine the Z value from the table first, and then you compare the tabulated Z with the calculated Z. Calculated Z is the one that you determine in the third step. Okay, so this is the decision rule. So you have to memorize lah. So there are actually two options. Previously, I just show how to use option 1, and that is sufficient. If I don't want to introduce both because it would mix you up. Okay, sometimes people, the students would do both and then they don't know what to do with that. Okay, you can only choose one. Just perform one option. Okay, if you stick to option 1, then do it. But option 2, maybe I don't show it, but it's about the p value. Okay, but I think the easiest one is the option 1. Okay, so don't get confused. It's either option 1 or 2. So let's say you calculate the Z table and then you have the Z calculated. You compare the two values, use these rules. So if it's Z computed is less than the Z table, then you conclude the H0 and the other way around. So, and also please don't forget this symbol. So whatever the negative value that comes out, after you have that symbol, that absolute, I mean, you consider the absolute value. So it means that you only consider the positive values. Okay, so sometimes the students might forget about this. So when you compare, let's say the Z computed is minus 2.3, and then you got Z tabulated positive 1.4. Because you don't remember this symbol, you say that this one is less than this. Sedangkan if you just consider the positive value of this is going to be 2.3 and it should be greater than 1.4 and you will make wrong decision. Okay, so don't forget this symbol, otherwise it will give you wrong decision. And then once you make the decision, this is decision, whether you conclude H0 or H1, null or alternative. And then the final step is to make a conclusion. So how to make the conclusion? You refer back to your hypothesis. What is your hypothesis all about? And it should be specific to the problem. So it means that you have to construct a proper sentence at alpha equal to 0.05. Don't repeat again in the conclusion that accept the null hypothesis. You should state it. The null hypothesis, whatever the mean is equal to whatever the value is given. Okay, so I'll stress it again after this. So that's basically all the 5 steps that you have to perform when you compare the 2 samples from the 2 populations. Okay, I hope that clear. So yeah, so the only thing is this part is a little bit different from the previous one. Sorry. Okay, let's have a look at the example. How are we gonna apply the 5 steps just now? A teacher wishes to compare the effectiveness of 2 teaching methods. The students are divided into 2 groups, and each group is taught using different methods. Okay. At the end of the course, an exam is given to all students. Group 1, okay, so this is given. The mean score. Group 2, the mean score is this one. This is the N value. The teacher claims that the second method used on group 2 will increase the score. Is this claim justified at the 5% level of significance? Earlier research for the 2 methods indicates that standard deviation 1 is 14, standard deviation 2 is 15. Okay, so now what information that we are provided with? So you have to understand the problems in order to know, especially when you construct the hypothesis, what you are referring to what, okay? So that's why you have to understand every problem specifically. So in this case, we are comparing 2 groups that are given 2 different teaching methods, okay? And it's stated this one, so it means that you know that actually each group in this case is representing population. Okay, so it means that this one is referring to population 1 and this is referring to population 2. So it doesn't mention directly, but that is what the problem is all about. Okay, alpha is given 5%. This one is given, so you know that it falls under the category when the standard deviations of the population are known. Okay. What else? Okay, this is very important. I want to stress out this statement because that will determine your hypothesis. The teacher claims that the second method used on group 2 will increase the score. Okay, now we are talking about population 1. Let's assign it to mu1. Okay, mu1 is population 1. Okay, don't forget this is referring to the sample of population 1, but population mean is actually the one that we want to compare. Because for any population, how to find an idea about the population, we have to analyze the samples. Okay, so when you want to construct the hypothesis, or your main aim is actually you want to compare the 2 population, P1, P2. That is the ultimate aim, okay? But in order to compare the 2 populations, you have to analyze the 2 samples derived from that populations. So I hope that clear, because this will help you to see the relevance of the hypothesis. So for the hypothesis, it means that here it has mu1 and this has mu2. Okay, since our aim is to compare the 2 means, the hypothesis, it could be, remember the null hypothesis, there is no difference, means that mu1 is equal to mu2. So the null hypothesis would be mu1 is equal to mu2. So see, when you construct the hypothesis, you are using mu. Mu is the mean of the population. This one is x bar is the mean of the sample. So that's why you don't define mean. Sorry, you don't define the sample mean in the hypothesis, okay? Because remember, our ultimate aim is to compare the population mean. To compare population means. Okay. So when you understand this, this will help you to construct the hypothesis correctly. So that's first one is null hypothesis. Alternative hypothesis. Okay. So let's say is this statement is not given, your default alternative hypothesis, you would say that mu1 is not equal to mu2, right? Because it's always opposite to the null. But since in this problem, this statement is given because the teacher claims that the second method used on group 2 will increase the score. So means that, yeah, it's mu1 is not equal to mu2, but there is a specific condition given that the teacher wants to test. So means that you can, the more specific way to construct the alternative hypothesis will be mu1 and mu2 will increase the score, means that mu2 will be greater than mu1. Okay, so that's how you construct a more specific alternative hypothesis. Okay, this one because of the problem states that way. Okay, if say this statement doesn't exist, you can just proceed with this way. Because if you say that mu1 is not equal to mu2, it could be mu1 is greater than mu2 or mu1 is less than mu2, right? It can be both. But this is just a general form of H1, or we can say default. Default means if there is no extra information given, you just use it. But if there is an extra information like this one, so you have to stick to the current problem. Okay, so in this case, this is more appropriate or more suitable. Okay, so that is the hypothesis. Okay, now let's proceed with the solution. I have the solution here. So here, how to solve it? Step 1, set the hypothesis. Okay, I've mentioned about this and this. Okay, so mu2 is greater than mu1. You can also put, but because we always write mu1 first, so but if you write this way also can. Okay, it's the same, right? Now step 2 is given, so you don't have to. You just state it alpha equal to 0.05. Step 3 is you have to compute the Z value. Okay, compute Z value based on this formula. So it's given to you in the exam. So you have to know that this Z value refers to the hypothesis testing with 2 populations. Okay, so how to use it? You just substitute the value because this one is referring to the sample 1 mean of sample 1, mean of sample 2, which is given in the question, 74.8 and 81.3. It's actually this one here, 81.3 minus. Yeah, so this is actually yeah, this one is this one. Okay, this is actually the one that you sini lah. Okay, right. So 74.8 minus 81.3, you got minus 6.5. Okay, and here is just you substitute the value. Alpha at the standard deviation 1, which is 14 divided by n1. N1 is 49. Okay, so you got this, and you got the Z value minus 2.23. Okay, that's the Z calculated. Okay, label in your workout, this Z represents which Z? Otherwise, you might get confused. Step 3, okay. Z calculated. And then step 4, okay, here I use option 2. Option 2. You can also determine Z tabulated or Z table, right? And you compare later with the Z calculated. Okay, here I will just to show how you use the option 2. Remember when I mentioned about the steps just now? Step 4, you have option 1 and option 2. I think option 1 I've shown in the previous lecture for one sample. So option 2, what does it mean with a p-value here? Okay, so once you have determined, let's say the Z calculated, right, this one. So how, what you're gonna do with option 2 step, you calculate the p-value. P-value means the tail area. Okay, so once you get the minus 2.23 and you sketch it on the graph. So this is the Z value of minus 2.23 and p-value is referring to the tail area here. Okay, so how are you going to find it? You can apply the symmetric rules, right? So it actually the same. This area is actually also the same p-value when Z is equal to positive 2.23. So it's because when you refer to the normal table, it's only given to you the right axis. So that's why you have to apply the symmetric rules. So when Z is equal to 2.23, so the value of the area, okay, remember this is 0.4871, is referring to this area. Don't get confused. That's why you have to know how to use the Z table, 0.4871. Because the Z, how to use this table, the area is given by the area is enclosed by this way, this region. So the Z value, right? Okay, but here, so here you want to find this tail area. It means that you have to know that the total area here is 0.5. Okay, this one you have to know by yourself. It's not given in the question. P-value or the tail area there is 0.5 minus 0.4871, which is 0.0129. Yeah? Okay, now here is 0.0129. So it should be the same with this. It's symmetric. So that's how you got this 0.0129. Now the next step for this one is to compare this p-value with the alpha value. This is alpha value which is 0.05. So the p-value is less than the alpha value. Okay, if you refer to the decision rule, if it is less, then you conclude H1 alternative, this one. Let's conclude H1. So in this case, reject the null or accept the alternative hypothesis. So that is the decision. Step 4 is more to making decision actually. Step 4 is making decision. Okay, so that's the decision. Okay, so if you do not want to use the p-value, you can use the Z. You have to find the Z value. Okay, how to find that Z value? You refer to the alpha value, the Z value. Sorry, this is you have to find the Z. Okay, this is referring. Jangan don't relate with this thing. That's why I don't want to compare the two methods side by side, because otherwise you would get confused. So this one, okay, you keep aside. Jangan relate dengan apa yang I explain after this, yang about the T. If let's say you want to find the T, okay. So if let's say you want to find the Z the Z tabulated. The Z tabulated, it means that you have to find from the table, you have to rely on the 0.05 alpha, okay? And then now, because if you are referring to the hypothesis, okay, I forgot to mention, this is actually when you have this one, this is a two-tell, we call it two-tell case, two-tell case, because it actually can be anything. It can be both, actually. It can be whether mu2 is greater than mu1, mu2 or less than mu1. So that's why it's called two-tell. But if let's say we only have like mu2 greater than mu1, like in this case, or if let's say our hypothesis is the other way around, so this is what we call a one-tell case. One-tell case. So means why this one is very important, because when you want to determine the Z table, before this because we are talking about two-tell in the previous topic, so that's why we have to divide that alpha into 2. Alpha equal to 0.05 into 2. So means that here is 0.025, here is 0.025. But since this problem is one-tell case because of this symbol, okay, this symbol. So whenever you want to find the Z table, you just have to consider that 0.05 tu dekat sini actually. Atau well, actually is either one lah, because at the end you nak tahu yang Z value tu. So let's say here, let's say one side, which is 0.05. Okay, sini lah, 0.05, because you want to find the Z value. So 0.05. So means that the area here is 0.5 minus 0.05, which is 0.45. Okay, now, so if you want to refer to the normal distribution table, 0.45, when the region is 0.45, you have to find from the inside here, okay, somewhere here, like actually 1.645, okay, 1.645. Okay, so means that the Z tabulated in this case is 0.445 lah. 0.45. Sorry, 1.65. 1.65. Okay. So this is the Z tabulated. Okay. So this Z value, dia tak kisah positive negative, sebab if you have this comparison, it doesn't matter because of this symbol, right? The absolute value. So your Z calculated, I hope you can still follow me. Okay, the Z calculated here is, okay, you want to compare the Z option 1 kan? Kalau guna option 1 ni, you want to compare the Z computed and Z tabulated. So our Z value is, Z calculated is 2.23 and tabulated is 165. It's actually greater. So Z calculated is greater than Z tabulated, 1.65. So which decision that you have to choose? Calculated greater, so you choose this one. So you can see that actually the decision will be the same at the end. So jangan buat dua-dua. Okay, don't perform both options. So you just choose option 1, option 2. Yang mana senang untuk you. Okay, so it's gonna lead you to the same decision. Just now kan, when we do the option 2, we accept the null, we accept the alternative as well, right? Accept alternative. So dia akan sama, okay. So kalau you tak faham yang Z tadi tu, you just guna P pun okay juga. Okay, which one yang you faham? Okay, right. So that is step 4. Step 5 is to make a conclusion. Okay, so when you make a conclusion, don't of course you relate it with which hypothesis that you accept, but you also have to mention specifically based on the problem. Okay, now we accept the alternative hypothesis. So what is your alternative hypothesis? Go back to your step 1. Step 1 is this one. This is your alternative hypothesis, or you put it in sentence. It means that the method 2 is better or score higher than method 1. So you have to construct in a sentence. I think I forgot the word here. At alpha equal to 0.05. Please add in your notes later. Okay. At alpha 0.05, the conclusion is the second method produced higher score than method 1. Okay, so that is going to be the conclusion. And conclusion normally is 2 marks. So if you don't write this sentence, you might lose 2 marks. Okay. All right, so that's how you solve it. Right, so the thing that you have to take note, which is different from the previous topic on one sample, is the Z calculation. All right, and this one is actually sama actually yang step make decision tu. Cuma you have to know how to determine the Z table and also the P value. Okay, and the rest is the same. At the end, you want to make a conclusion. Which one is, what the conclusion is. So that is this one, okay, which is actually in lecture 6. When the standard deviation of the populations are known. Okay, in the second case, when the standard deviation of the populations are unknown, so we would use t-test. Just now Z distribution. So in the second situation, we're going to use t-test. T-test. Ini pun sama kan dengan yang before, Z and T. So under this, there are going to be 2 types of samples, independent samples and dependent samples. So this one is a bit lengthy. Okay. Right, let's have a look first. 2, when the standard deviation are unknown. Okay, there are different versions of t-test depending on whether the 2 samples are independent or dependent or paired. Dependent means like it is associated, like when it deals with the measurement before and after, or whatever the pair is. Yeah? Independent means like is independent, there is no connection. Okay. Yeah, I think we have talked about independent or dependent samples before. Okay, and then so these are examples of how to design for independent samples with 20 subjects. So normally, like independent, when you compare the two samples, the order is not really it's not based on order. But if let's say you have dependent samples, yeah, let's say you have the same subject, okay, the same subject, people maybe consume product A, and then the same set of people consume product B, and you want to compare side by side like this. So that is dependent samples. Whereas if let's say you want to have sample A, you don't care about the order. Like you compare randomly between the 2 samples. So basically that's the difference between independent and dependent. Okay, let's have a look at the things further. Independent 2 samples. Okay. Okay, for independent samples, there are 2 cases of variance. First one is pool variance, and the second one is separate variances. Okay. You accept first, nanti I cerita. So this one, I think this will not be the focus of the topic. We would talk about pool variance more than the separate variance. So means that yang ni formula ni tak depends lah. I think the coordinator will not release a question on this. But this is just for you to know the t-test. All right. For the pool variance, it is pool variance when the variances are assumed equal. Okay, itu dia punya definition. And this is the formula of the pool variance. This is SP ni, pool. S square is variance. Bila ada SP tu is pool variance. Okay, I think this is the formula that you need to know. And this is the t-test. Okay, the t-test. Okay. So the formulas will be given. Don't worry about the formula. I think you will understand the statements more if you are given the examples. Okay, let's have a look at the steps. Okay, now these are the steps. So when both are unknown and for independent samples. Okay, basically, so what are the steps? The first one is to set the hypothesis, same thing, null and alternative. Second step, to set or to define the alpha. Okay, for this one, okay, step 3, then you have to calculate the pool variance. So this is the difference between the previous one. So this is the formula. And then step 4 is to calculate the t. Okay, the t computed. This is the formula. Step 5, make a decision. Make a decision by comparing t computed and t table. Okay. So this is the decision rule. Okay. Alternatively, you can use the p-value method. Okay, that's option 1 and 2, the same thing. And the pattern of the decision is the same. Just now we have z, but this one is we have t. Okay, so if the t computed is less than t tabulated, we conclude this, and the other way around. Okay, now step 6 is to make a conclusion. Yeah. So, right, let's have a look at the example directly so that you can relate with the steps just now. In a packing plant, a machine packs cartons with jars. The time for both new and old machines to pack 10 cartons are recorded. The results in seconds are shown in the following table. So these are the 2 samples. And these are independent samples because it's not mentioned that we have to relate one with the other one in the other sample. Okay, so this is independent samples. Okay, so this is the mean of the sample 1, mean of the sample 2. Okay, now don't get confused. This one is the standard deviation of sample, not the standard deviation of the population. Okay, so this is the standard deviation of the sample. So we are talking about sample. This is sample 1 from population 1. And this is sample 2 from population 2. Okay, so now the standard deviation of the population are unknown. Yeah, unlike the previous example where they are given. Do the data provide sufficient evidence to conclude that on the average, the time taken for the new machine to pack is different from the old machine? Okay, when you read the sentence of the problem, make sure you read carefully, right? And try to see what's the focus of the question, because it's different from one problem to another. Do the data provided on which the time taken for the new machine to pack is different. Okay, the word different here is very important. Why? Because it will lead to your alternative hypothesis. So it means that, now remember when we talk about the hypothesis, we are comparing the population mean, right? So for the null hypothesis, the mu1, we assume to be equal to mu2. And for the alternative hypothesis, because in the previous example, it's stated that method 2 is greater than method 1, and so that's why we set the hypothesis, the alternative hypothesis, according to that statement. But here is different. Different means like you do not know whether it's less or more. So it could you have to set it not equal. So that's why it's very important to identify the keywords from the problem, because that will give you the hint for the hypothesis. So because of that, you set this one this way. Okay. Perform the required hypothesis test at 5% level of significance. So alpha is 0.05. Assume the data came from independent, normal distribution, and equal variance. So means this one is pool variance. Pool variance. So remember when we talk about the variance just now? Yeah, this one. So means you have to use this formula, you have to use this formula. Okay. Okay, let's have a look at the things that we have to solve. Okay, first one is set the hypothesis. See, this one is this one. You can also transfer, you can write this way or you can write this way, also the same. Okay, you transfer the mu2 into the left, the right. Okay, step 2, alpha. Step 3 is to calculate SP, the pool variance, SP squared. Just apply the formula. So you have to know the symbols here. S1 is the standard deviation of sample 1, S2 standard deviation of sample 2, and 1 is the n size of the size of sample 1. Okay, so when you calculate this, this is the value of SP square, the pool variance. Now step 4 is to compute the T value, right, using this formula. So the reason why you have to calculate the SP square, because you need that in this one. So that's why you have to calculate SP square first. Then apply the T formula here. Okay, this one is given, right? 42. 43 is also given in the question. And the rest, yeah. And you get this value, the T value, right? T computed. Now, the next thing is to find T table or T tabulated, because you want to compare the two values. So how you want to find the T tabulated? So remember the T distribution table is the same T table that we used last time, but what kind of information that you need here? So you need alpha, okay, and then DF, the degree of freedom. So the degree of freedom, this is the formula. It's different from the previous formula because this one referring to two populations. So N1 plus N2 minus 2, that's the formula for degree of freedom for two populations. Okay, so here the alpha, you have to divide by 2 because we in the T table, we are talking about upper tail area, right? Upper tail area. So that's why you have upper and lower. Upper is on the right, lower is on the left. So 0.05 alpha tadi divide by 2, 0.025. So this is the value that you have to refer in the T table. Okay, now we have degree of freedom 18. Upper tail area is this. So let's have a look at the T table. 0.025, the upper tail area, and then DF just now is 18. Okay, so the value that we are looking for is this one. All right. So 2.101. So that is T tabulated or T table. Okay, 2.101. 2.101, yeah. So that's how you got this value. Now, the next thing is to compare the T tabulated and the T computed. This one, T computed. This is T tabulated. Okay, so that's why you need to see. This one is negative, kan? But you ignore the negative values. Don't forget it. So it means that which one is T computed is actually greater than T tabulated, isn't it? T computed is greater. Yeah. So it falls under this situation. So it means that you conclude the alternative hypothesis. So that's the decision. Okay, so this one jangan buat lah. I think because you have compared the T tabulated and T tabulated and T computed. So you no need to. This is actually option 2, but it is included in this lecture notes. So to avoid confusion, don't do both. Never do both because you will get the same conclusion at the end, like this one. Sama kan? So just do this one lah. Kalau you rasa cari T table lagi senang, just stick with it. Okay, don't mix up. Otherwise, you get confused. Okay, so now you know that you accept the alternative hypothesis. So the conclusion, okay, write proper sentence at alpha at 5% level of significance. Okay, if let's say you forgot what your hypothesis is, means that here the mu1 is not equal to mu2. Means the time taken for the both machines to pack is different because the machines actually represent the population. Population. Basically, the keyword is different. It's not the same. It's not equal. Okay. So that's it. That's how you solve the problems for unknown standard deviation of the population. Any questions so far? Do you need a break? Okay. This one, I leave it first. Okay. We just proceed with, I think this is another example. Ini example untuk separate variance. Separate variance, which is the first case yang bukan pool. So that's why the formula is different over here. Dia sama je, tengok trend dia sama je. You just follow the steps tu, and it's the same. Okay, maybe I skip this one. This is equal variance. It will be mentioned in the question what kind of variance the data has. Okay, whether it has equal variance or separate variance. So you have to take note on that because that will determine the T formula. Okay, this one. This is another example of equal variances. It's actually the same. You find the T, find the SP first, find the T, and then find the T calculated, find the T tabulated, compare the two T, make decision based on the rule, make a conclusion. Okay, then you can go through by yourself. Okay, I'll just go directly into the last part, which is the dependent p-test. Just now we are talking about independent samples for t-test. Okay, now dependent t-test. What kind of dependent samples normally, what kind of samples that are dependent? So it's either paired sample, as I said just now, if let's say you want to compare the same subject tested with product A or and then the same subject tested with product B, and you want to compare side by side. I mean, means that this is 1, 2, 3. You want to compare with 1, 2, 3. Yeah? So that is paired. Yeah? So that is paired sample. Dependent samples could also be repeated measures. So if let's say you are the same person having different tests, you want to compare, like for Halim, how much Halim scored between test 1 and test 2. So it means that it's repeated. Or maybe if let's say patients, a group of patients given drug or medicine A and then drug B. Okay. No, that one also can, but if let's say patients glucose, let's say you want to measure certain things like glucose level before taking drugs and after taking drugs, but you're talking about the same group of patients. So it is a repeated measurement as well. Okay, so that's also fall under the category of dependent data. Okay, let's go directly into what is the difference between independent and dependent. The difference is in terms of the T formula, but the T formula is a bit simpler than the T formula for the independent samples. Okay, so here the T, this D bar refers to the mean of the paired difference. Okay, I'll show later what does this mean. And then this one is standard error of the difference. The whole thing here is standard error of the difference. The S here is referring to the standard deviation. Okay. Let's have a look at the question. Comparison of peak expiratory flow rate before and after a walk on a hot day for a random sample of 9 asthmatics. Perform the required hypothesis test at the 5% level of significance. So in this example, each row represents the same subject. Okay, so see here, this one is actually the same subject. This is referring to the same subject. And you measure these subjects before and after. So whenever you see the word, the keyword before and after, you know that these are dependent samples. Yeah, because it couldn't be independent, dependent samples. So what does it mean? You know that you have to use the T formula, this one, this. Right, so how to solve this problem? Okay, it's actually the same like the independent sample. So let's see the difference. So since you got some ideas on the steps, you set the hypothesis, but the content will be, the different will be the calculation, but at the end, decision and conclusion is the same. Right, now hypothesis, okay, so you have to know what kind of things that you are going to compare. So you are going to compare before and after, and you assume it to be like represent population, two populations. So that's why you set it mu1 and mu2. And for the now, there is no difference. Or you can say in a sentence, what kind of things here? Yeah, the expiratory flow rate before and after walk is similar. Similar means no difference. And the alternative hypothesis, so since it doesn't mention any condition, whether it's before is greater or after is greater than the other, so you can set the default symbol or condition where the mu1 is not equal to mu2. Okay, remember, if it's not stated specifically like the previous example, you just stick to this. You just stick to the symbol. So it's not similar. So that's the alternative hypothesis. So you know that they are dependent, so you have to use this T formula. Okay, and then step 2, alpha is given. Is it given? Yeah, given alpha 0.05. Okay, step 3, to compute the test statistics, which is this this T value that you have to solve. So it looks simple, but actually you have to do a little bit steps before that. Okay, so since this is the data given to you, for these dependent samples, it's better to construct a set of data in vertical form like this, before after, so that it's much easier for you to calculate, because you need to calculate the difference. So it's much easier for you to compare it this way. Okay, so since just now if you see that it's given in the horizontal mode kan, boleh jugalah, tapi like me, I would feel easier to have the data like this. Okay, so what you have to calculate before you apply this formula, you have to calculate the difference for each of the data. Okay, for example, you just set difference and then find the difference, 302 minus 300. Okay, now it doesn't matter actually whether you want to minus after, minus before, or before minus after, but just stick to one way. Let's say you subtract, let's say you before minus after, you got 12, right? 312 minus 300, so that's 12. So in the following data, you also have to follow the same order lah. 242 minus 201, 340 minus 232, so that you're gonna have consistent format of the symbol. So if let's say you minus 300 minus 312, you got minus 12. minus 41, like after minus before, minus 108. But at the end, dia tak ada beza dekat sini actually. Okay, so the key thing here, you have to stick to only one ni lah, one form. Mana-mana boleh actually. Sebab at the end dia akan, you will see later how it differs, how it will be. Dia sebenarnya dia tak kisah, tapi you kena stick to one apa? One form lah, before, after, ataupun anything. Okay. So let's say here, we subtract before minus after. So find the difference. And then the n here is referring to the how many samples, how many pairs. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's how you got 9. Okay, and this is the total of the difference. Means that 12 plus 41 plus this is this, you got 505. Okay, and the mean is when we have the bar over here, that's the mean. So means that is the difference, the total difference divided by the n, which is 505 divided by 9, you got 56.11. Okay, so that's the formula that you have, that's the value that you have to substitute into here, right? And the S, okay, now S ada tak bagi tadi? S is not given. Okay, this is another thing that you have to find out, where you have to find the S using the formula. Remember tak formula yang the previous lecture? I pun tak ingat tak formula tu. 1 minus 1 over n. Hold on. Ada tak bagi kat sini? You have to find this one also. Where's the formula? Oh yeah, this one. Okay. S square okay, So remember this formula, the S variance, I think we study in LU1, okay? So here, this one, you kena tukar kepada D minus D bar square, okay? So this one. So this is how you want to find the S. You carilah ni square root ni. Okay, so how you gonna apply that? N is 9, okay? If let's say I want to solve this, 9 minus 1, 8, okay? And then this is the summation of, let's say 12. 12 minus D bar here is 56 point, and then you can create like a big bracket, okay? 12 minus, 12 is referring to each of this difference, which is the D. Okay, yang ini adalah D. Okay, 12 minus 56.11 square plus 41 minus 56.11 square plus, okay, 108 minus 56.11 square sampai 59. You got it? Sampai sini. 59. Yeah. 59 minus 56.11 square. Okay, you close the bracket and then you solve it. Don't forget the 1/8 over here. So then, and this is actually S square. So whatever the value, you have to find the square root of it in order to find the S. So that's how you got the S and you substitute into this formula. So dia nampak, the formula of T looks simple, but actually you have to find the D and you also have to find the S. So there are two things that you have to do beforehand before you can solve the T. So at the end, you will get this value. So try, later you can try by yourself whether you got the value of 34.174 or not, okay, by applying this thing. Okay, this is just for you to practice lah, how to find the S. Okay, now once you got the T, which is, in this case is 4.9. Okay. So that is the T calculated. And then you have to find the T tabulated. Okay, T tabulated. Apply lah yang this one. This is alpha. Upper tail area you have to divide by 2. So means that 0.05 divided by 2. Then you got 0.025. The degree of freedom in this case is n minus 1. It's different from the previous one, which is n1 plus n2 minus 2 kan. So this is n minus 1. N is the number of pairs, which is 9. 9 minus 1 is 8. So how you find from the table, T, upper tail area 0.025, degree of freedom 8. You got this T value 2.306. Okay, the reason why I said just now, when you find the D, it doesn't matter whether you 312 minus 200 or 200 minus 312. Tapi you kena stick pada satu style yang sama. Kalau if let's say you after minus before, you have to go through everything after minus before. You don't mix up, okay? So the reason why, because when you make a comparison, dia ada absolute value tu kan. Remember the rules of the comparison? It has this symbol. So it doesn't matter actually the negative value because you are comparing the positive value only. So whether you got just now minus 4 and you compare, like whatever the T value that you got for the calculated, you only consider the positive values, okay? So that's the reason kenapa dia tak ni lah, why it doesn't matter. Where is it? Okay. So in this case, when we compare, the calculated is 4.9 is greater than 306. So you accept the alternative hypothesis or you reject the null hypothesis. You can say either you say reject null, accept alternative, okay? So that's the decision. So the conclusion is you reject null means you go back to your hypothesis in the first step. What was the hypothesis? So in this case, the expiratory flow rate before and after the war is not equal actually. It's different. Okay, it's different. Okay, it's not equal. So it's different. So that's the conclusion. Okay, I think this is how you solve the t-test two populations dependent samples. Any questions? I think that's the end because I nak habiskan cepat sebenarnya. The rest is you can do the exercise by yourself, okay? Right, so basically what we have covered, okay, these are some exercises that you can do. Apply step 2, compare dengan kawan, okay? Compare with a number of you, macam 3-4 orang ke, and then you see the answer sama ke tak. Kalau you apply, you follow the steps kan, dia tak susah sebenarnya, this statistics. You follow the steps, dia sama je. Cuma you kena faham every problem tu, tengok what is the focus of the question. Especially that could help you to determine the hypothesis. Okay. So I don't think so I have the answer for this. Okay. So please discuss among yourself. Yeah. So basically today what we have covered, statistical analysis of two populations mean. We compare the two populations by comparing the two samples derived from the two populations. So there are two situations when the standard deviation of the populations are known. We use the Z distribution. And the second one is when the two populations, when the standard deviations of the populations are unknown, we use T distribution or t-test. Okay, so means that you have to familiarize yourself with the steps. Step 1 tadi sampai the last step, make conclusion. But the difference between each situation is the calculation, whether you calculate the Z, whether you calculate the T. And for this one ada independent dengan dependent samples. Dia ada beza lagi lah yang T tu. What makes the difference between these two situations or these two samples or data is the T formula. Okay, you can faham the question. You can faham the problem first in order to know whether they are independent samples or dependent, because that will lead to different T formula. And the rest are the same. Macam mana nak cari T table, you compare T table, T tabulated dengan T computed, and then the rule is the same kan, decision rule sama je. Yang bezanya adalah the formula here, the formula for Z. Okay, there is a question just now. Can the null and alternative hypothesis can be written in sentences? Yes, yes. So if let's say you want to make it more understand for you kan, you kena tulislah dalam sentences. The null hypothesis says that remember the ultimate aim is to compare the population. That's why the hypothesis always talk about mu1, mu2. Okay, bukan X. This is mean of the sample. Mean of sample. Kita analyze sample tu just to give idea about the population. Tapi our ultimate aim is to compare the population. That's why we use this one. This is population mean. Okay. I hope that is clear for you. Population mean. Okay, that's it for today. So our mid-semester exam will be up to LU2, the whole LU2. So now you can proceed with your tutorial. I have given the questions. Proceed with the problems related to today's topic. Okay, and then submit by end of this week, is it? So that I can have some time to give feedback to you, okay? So that you know your works. Okay, any question for today's lecture?
No, Doctor.
Okay, I will post the information about the mid-semester exam later, like the format, how many questions. It carries, I think 30%. 30%. Yeah, 60. 60, yes. 30%. 30% goes to tutorials, all tutorials, tutorial 1 and 4. 30% goes to mid-semester exam and 40% goes to final exam. So that makes 100% of the marks for this course. Okay. Tak ada lagi soalan? So, right. Okay, kalau tak ada, then we can disperse. Thank you very much for your attention.
Thank you, Doctor.
Thank you, Doctor.
Okay.
Have a nice day.
Thank you.